Okay guys, so today we're going to start going into linear functions and what is a linear function. By definition, a function is linear if the rate of change, aka slope, is constant between any two sets of points. Okay, then we have our equation y equals mx plus b. So that m and that b are very important, so we need to understand what the m represents and what the b represents. So off of m, we need to know that m is known as slope, aka rate of change. So slope is m, also known as rate of change. So what does that b represent? B represents the y-intercept, and it might be nice to know it also as the starting point. The starting point. So that's going to be useful when we're in word problems. Where does it start from? Your y-intercept. And this is kind of repetitive, but we know a linear function has a constant rate of change. It has to be the same or else it's not linear. Okay, so we kind of went over slope yesterday, but again, let's go over it. We know rate of change, aka slope, is the change in, remember this guy means y, so you might want to highlight that. I know that this guy right here means y. All over the change in the x's. And another way you might see that is delta y, change in y over the change in x. So this little delta symbol just means the change in the y's over the change in the x's. Y's rise, so it's also known as rise over run. All right, so now let's hop into some word problems. Okay, little Jimmy is saving money by buying a new toy. He already has $2, but will save $3 every week. Please fill out the following to represent his total savings as a function of the number of weeks. All right, so remember when we do word problems, we want to use cubes to help us break it down. C stands for circle the key numbers. So my key numbers here is he already has $2 and he's going to get $3 every week. Okay, then U is underline the question. Well, it's not necessarily a question, but it's telling us what to do. We're going to be filling out the following to represent his total savings as a function of the number of weeks. That's what it's telling us to do. This is box any math action words, okay? And the one that I see that we want to box is where it says $3 every week. Okay, so let's box this. If it's happening every week, $3 every week, I know that we're going to be multiplying here. Let's put an X for multiply. E, eliminate any unnecessary information. Well, it all looks pretty good to me. It's all stuff that we need to come up with our function. And then S is solve. Okay, so let's fill out the table. When x is 0, let's figure out what y is. All right, well, in the story, let's figure out what is x, what is y. Okay, so in here, it tells me that he has a total savings as a function of the number of weeks. I'm going to highlight those two guys. Total savings, number of weeks. So let's label here. Let's figure out what is x, what is y. Okay, x is always your independent, okay? So our x is going to be the number of weeks. And my y is going to be the total savings. Usually, I'm not going to say always, but usually if you have a time is your x. So not always, but usually. Okay, so X is going to stand for the number of weeks, Y is going to talk about our total savings. So in our table, we're trying to figure out what will our total savings be if we are starting at 0 weeks. Well, in the story it tells us that we already have $2, so I know that's what we're starting with. And remember, your starting point is your B, your y-intercept. Okay, well, how does it change from there? I know he's starting with $2, but after a week goes by, how much money is he going to have from there? Next and next. Okay, and the way we come up with that part is right here. It tells us that he's going to save, he has a $3 allowance every week. So I know every week it's going to go up by 3. Okay, so I know that's going to be my rate of change. It's changing by $3 every week, where rate of change is the M. So now we can write our equation. Y equals 3x plus 2. Y equals, we know M was 3, our rate of change was 3, x plus our starting point plus 2. That's how I came up with this equation. Okay, so now what we can do is we can plug in our x values here to figure out what our y value is, or we can use our table, graph it, and open the table to fill this out. So I just like practicing using my table and graph, so let's go ahead and do that. So I'm going to add a graph, and I'm going to type in my equation, which is 3x plus 2. Now I'm going to open my table, which remember we press Control T. So we're going to go to where x is 1. When x is 1, I know y is 5, which means after 1 week he'll have $5, and that should make sense because he starts with $2. And after 1 week, he'll have a $3 allowance. 2 plus 3 is 5. All right, so now we want to go to 3 weeks. Well, at 3 weeks, he's going to have $11. And at 4 weeks, he's going to have $14. So remember, you can graph and open your table, or you can plug in your x values. So 3 times 0 plus 2 gives you the 2. Or when x is 1, 3 times 1 plus 2 gives you 5. When x is 3, 3 times 3 plus 2 gives you the 11. So you can either plug in your x value and calculate your y, or you can go graph it and open the table. Either one works for me. Okay, so it tells us to find the rate of change from the table, and then we're going to graph it, okay? And so I'm just going to jot down our table again real quick. So I'm going to jot down this table right here so we can practice finding it. And it was 0, 1, 3, 4. Is 2, 5, 11, and 14. Okay, so remember from yesterday, we need to find the changes in the y's and the changes in the x's. So as I look at my y's, 2, 5, 11, 14, I notice they're getting bigger, so I know I'm adding, and I'm adding 3. Then I look at my x's, I notice they're getting bigger, 0, 1, 3, 4, so I'm adding, and to get to 0 to 1, we added 1. Well, we do the changes in the y's over the changes in our x's. So on top I'm going to have a positive 3, on bottom I'm going to have a 1. 3 divided by 3 is a positive 3. All right, and we already knew that, but just practicing, that's how we find slope from a table. Okay, so now let's put it on our graph. Well, in order to put it on our graph, we need our starting point. Well, remember we said he's going to start with $2. So here's my y-intercept, my starting point. So on my graph, I'm going to go put a dot on the y-intercept 2. So on the y-axis, go put a dot at 2. Okay, so how do I move to my next point? Okay, so remember how we said slope is like rise over run? Okay, so notice when it's in fraction form, 3 over 1. That means I'm going to rise 3 from my starting point, run 1. So from here, I'm going to rise 3, 1, 2, 3, run 1, and put a new dot. So from my starting point, I had a rise 3, run 1. 1, 2, 3, run 1. All right, do it again. Rise 3, run 1. Put a new dot. And that's all we can fit on our graph, so we're going to line it up. So in order to graph it, you have to have your starting point, which is your y-intercept, and then your slope tells you how to move. Well, my slope was 3, which is 3 over 1, so I rise 3, run 1. So he started here. My y-intercept was 2. He started with $2, and then every week he gets $3, so we go up by 3 over 1. Okay, given the following table, we're going to write our linear equation and then we're going to graph. Okay, so we need to find our rate of change first. That's our first step. So to find our rate of change, we're going to look at our y values. I notice it's 0, 2, 3, 5. I know it's going up, so we're adding. And to get from 0 to 2, we added 2. Then we look at our x values. I look at my x's. I'm going from -4, 0 to 6. They're also going up, so I'm going to add. And to get from -4 to 0, we have to add 4. Okay, so we put our fraction. We know y's rise, so this one goes on top, a positive 2. My x's go on bottom, a positive 4. And we simplify. 2 over 4 simplifies to 1/2. This is my rate of change. This is the m value. So we found the rate of change. That's the first part if we want to write our equation. So it continues over here. So we already figured out what m was. We know that m is 1/2. Okay, now we have to find b, our starting point. What is our y-intercept? So when we look at our table, we need the y-intercept is you start when x is 0. So you need to go find where x is 0. So I know our starting point is at 2. My y-intercept is 2. Okay, so now we can write our equation. Now that we know our slope, we found that here was 1/2. We know our y-intercept is 2 because I found when x is 0, it starts at 0, right? Y is 2, my y-intercept. Okay, so now that I have my slope and I have my y-intercept, I can write my equation. So I'm going to zoom back in here. So y equals 1/2 x plus 2. Okay, let's put it on the graph. Okay, we always start by our y-intercept, our starting point. So on the y-axis, our starting point is at 2, so I'm going to go put a dot there. I'm going to have to zoom in some. Okay, so our slope tells us how to move from our starting point. Well, our slope is 1/2, which means I'm going to have to rise 1, run 2. So from my starting point, I'm going to rise 1, run 2. There it is. That's my new dot. Okay, so from my new dot, I'm going to have to do it again. Rise 1, run 2. My new point. From your new point, rise 1, run 2. You do it over and over again. Rise 1, run 2. Sorry, my dots are kind of ugly. Rise 1, run 2, and then I'm out of space. Okay, so we have all the points that we can fit on there. So now what we need to do is just turn it into a solid line. It's pretty ugly, but one more line will continue all the way across the graph. So this is what it would look like for the equation y equals 1/2 x plus 2. Remember, we started at our starting point. Y-intercept is 2, so on the y-axis we go to 2. My slope was 1/2, so we rise 1, run 2. Rise 1, run 2. So on and so forth. Okay, so on this time we're giving a graph, and it's asking for a rate of change. So remember, on a graph, we want to start by picking 2 good points. Okay, remember, good points are the ones that go like this right here. This line is made up of an infinite number of points, but you wouldn't want to pick this point because notice it doesn't go through the intersection of a grid. You want to pick points that go through these intersections. So for example, here's a good one. And now we need to pick another good one. So I see, boom. Okay, after we pick 2 easy points, what we're going to do is connect them to make a triangle. And I have to figure out how much did it rise, how much did it run. Well, notice each of these little lines are marked by 1, because from here, 0 to 5, 1, 2, 3, 4, 5. So each of these boxes represents 1. So let's see how much does it rise. From here to here, it goes up 1, 2, 3 boxes. And let's see how much does it run. So it runs 1 box. So remember, it's rise over run. Well, it rises 3, it runs 1, but when we do a graph, you have to pay attention to the direction of the line. Remember, you read it like a book, from left to right. As I go from left to right, notice that line is going down. Because it's going down, I know it has to be a negative. All right, so all we have to do is simplify now. What is negative 3 over 1 simplified? Negative 3. And that's our m, that's our slope. So let's repeat. How do we find slope from a graph? You pick 2 easy points, you turn it into a triangle. You figure out how much does it rise over how much does it run. Don't forget to pay attention to which direction the line is going. Well, since the line is going down from left to right, I know it has to be a negative slope. Okay, cool. So that's the first part of this, so we can write our equation. The rest of it's on the back. So we found that m was negative 3. Now all we have to do is find b. So we know the m. Now all we have to do is find b. Remember, b is the y-intercept. So let's go back to our graph. The y-intercept. So we need to be looking at the y-axis. So it crosses the y-axis right here. So you might want to put an arrow to that. That is your y-intercept. And where does it cross that y-axis at? Well, that is down 1, 2. So down 2 would be a negative 2. Okay, so we figured out our slope. We now know our y-intercept. We have everything we need to finish that equation. So our equation is y equals negative 3x minus 2. All right, so now that we have our equation, let's go fill out our table. Okay, so let's go graph negative 3x minus 2. So new document, never save. I'm going to add a graph, and this time my equation is negative 3x minus 2. All right, so I'm going to open my table. Control T. All right, so it wants me to go where x is negative 3. Remember, your x's are the first column, your y's are the second column. So I want to go find x is negative 3. X is negative 3, y is 7. Now I need to go where x is negative 2. Well, x is negative 2, y is 4. Okay, notice this is a y value. So under the y's, I need to go find negative 2. So I'm looking here for negative 2. So when y is negative 2, x is 0. Now let's go find where y is negative 5. When y is negative 5, x is 1. And then finally, I need to find where y is negative 8. Oop, passed it. When y is negative 8, the x value is 2. So guys, after we find our equation, after we write the equation, remember before you can write the equation, you have to find m, you have to find slope, and you have to find b, your y-intercept. Once you have that, you can graph that equation and then fill out any table. Also, I want to point your attention to here. Notice we said the y-intercept was negative 2, and if you look in your table, don't forget that your y-intercept is when the x value is 0. Negative 2, that's your y-intercept. Okay. Number 4, word problem. So let's do cubes, but let's read it first. It says Sarah's dog is overweight. The vet put the dog on a diet. The table below shows the dog's weight, W, as a function of time in weeks T. Oops. Okay. As a function of time in weeks T, which equation best describes this data? So T is weeks, this is W is weight of the dog. So after 1 week, the dog is 95 pounds. After 2 weeks, the dog is 92 pounds, so on and so forth. All right. Okay, so we're trying to figure out which of these equations match this table. Well, remember, in order to find the equation, we need to find M, and we need to find M, which is slope, and B is y-intercept, the starting point. Okay. In a table, this is always your x, and this is always your y, no matter what letter. So instead of x, they're letting t be x, and they're letting w be y. All right, so let's find our slope. So look at your y values, 95, 92, 89. I know it's going down, so that's subtraction. And it's going down by 95 minus 3 will give you the 92. 1, 2, 3. Weeks is going up, so that's addition. And to get from 1 to 2, we add 1. Dang it. So rise, we put the y first, negative 3 over 1, and my slope should be a negative 3. And that should make sense because if your dog is overweight and you put it on a diet, doesn't it lose weight? So losing weight, so having a negative slope makes sense. So I know I can mark off A and B. A and B have positive slope. That means that dog would be gaining weight. So boom, here we are. I know my dog is losing 3 pounds every week. That's my rate of change. All right, so now we have to find the y-intercept. Is the y-intercept 98 or is the y-intercept 95? Where is this dog starting from? Okay, well, if I look at week 1, it says 95. Well, that's not its starting point because this is the dog's weight after being on the diet for 1 week. So I need to find when x is 0. Okay, well, I know it's subtracting 3 every time. So if I go backwards, I know it's going to be adding 3, right? So to get from 95, I subtracted 3 to get to 92. Subtract 3 to get to 89. But I need to go to week 0, so I need to go backwards. So after week 1, I know he's lost 3 pounds, so he started at 98 pounds, add 3. So that makes our answer C. So if my rate of change is negative 3, that means that dog is losing 3 pounds per week. Which means I need to go backwards, so I know that dog started at 98 pounds. After 1 week, he lost 3 pounds and now is at 95 pounds. After another week, he's lost another 3 pounds and is now at 92 pounds. So remember, your y-intercept is always your starting point when x is 0. This is a car rental charge is $100 plus 30 cents per mile traveled. Determine determine the equation of the line that represents the cost of the number of miles traveled and then graph it, which we can scratch off graph it. All we're doing is trying to find the equation. Okay. So my key numbers is $100 and then 30 cents per mile. Give me 1 second, I'm gonna clear this out the way. There we go. Okay, so those are my key numbers. We're gonna underline the question, determine the equation. It's not really a question, it's just telling us what to do. We're gonna come up with the equation. And then box any math words. Well, plus clearly means plus. And then I want to box that word that says per. The word per, the word every, that's is a math word for multiply. Also, if you see per something, that's also a dead giveaway for a slope. So when you go to buy a car, no matter how far you take it, you're going to have to pay the $100. So the base fee is $100. Plus, you're going to have to pay 30 cents per mile. So 30 cents for every single mile. All right? Okay, so which of these equations match that story? All right, so let's think of silly ones. I know my starting point is 100. Your starting point is your y-intercept. So let's write y equals mx plus b. Well, I know we are starting at 100. So b is the number that's by itself. And I know we're starting at a $100 fee. So I know it can't be A. That's saying it's starting at 30 cents. I know it can't be B, because B is starting at a negative 30 cents. So now between C and D, they both say 100, but the difference here is this is a negative 100, this is a positive 100. So by default, I already know my answer is D based off of the starting point only. I know we're going to start at $100. So positive 100, you have to pay 100. Okay, 30 cents per mile. This is a dead giveaway for your slope, your rate of change. So 30 cents for every mile plus the $100 fee. Let's go back and talk about some of the other ones. This one is saying it costs $100 for every mile. No way. It does not cost $100 for every mile. Wrong. Both of those say that. C and D are closely related, but on C it's telling you you're going to pay 30 cents per mile, but you get to take away $100. They're not giving you $100 off. It says plus. It's 30 cents for every mile plus that $100 fee. That's why C is wrong. All right, bye guys.